Hello everyone, welcome to the 2014 PAT paper. My name is Kat, I am the Physics Access Officer, and today I'm going to be taking you through question 5 on this paper. This question is a maths question, and it asks us to consider the shape below, where we've got 3 circles and a triangle inside. We are asked to calculate the area of the equilateral triangle, which is not enclosed by the circle, which is shaded in black. First things first, always with problems, is consider what we are assuming. To solve this problem, I am going to make the assumption that the vertices of my triangle occur at the center of the circles. So my assumption is that the vertices of the triangle occur at circle centers. And this will make the problem significantly easier to solve. The area that I'm trying to find, this little shaded shape here, I'm going to find by taking the area of the whole equilateral triangle and subtracting 3 of these segments of my circles. So 3 of the shaded circle segments. Now that I've got this far, actually it's not too bad. I'm going to take it one at a time. I'm going to calculate the area of the triangle, the area of one of the segments, and put it all together. So let's have a look at this triangle. I know it's an equilateral triangle, which means I know that the angles are all 60 degrees. I know it has a length of side 2r, meaning that each of these sections is r. To calculate the area of a triangle, I know that the formula is 1/2 times the base times the perpendicular height. Sketch this over to one side so that it's nice and clear for you. 2r along here, r along here. Perpendicular height is the one that I'm trying to find. There are lots of different ways of doing this. I'm going for the super simple, taking the tan of 60 degrees being equal to my perpendicular height divided by r. Using our trig identities, I come straight away to the fact that my perpendicular height is h tan 60 or √3r. Popping back over to my formula for the area of the triangle, I now have my triangle is 1/2 of the base of my triangle, which is 2r, multiplied by my perpendicular height, which is √3r, giving the overall area for my triangle as √3r squared. We're halfway there. Next thing I need to do is find the area of my circle segments. I'm going to use a new piece of paper for this just so we've got a bit more space. So for this, I'm going to use the fact that the angle at the center of a circle out of the total of 360 is in the same ratio as the sector area out of the full circle area, pi r squared. Because it's an equilateral triangle, as I already marked in, 60 out of 360 is my area out of pi r squared. My sector area is therefore 1/6 of pi r squared, and 3 times my sector area is 3/6 or 1/2 of pi r squared. I now have both of the pieces of information which I need to calculate the area of my shaded section, the area of the triangle, and 3 times the area of the shaded segment. Putting this in total, the area of my shaded segment is √3r squared, subtract 1/2 of pi r squared, a little bit of tidying up even though we're pretty much there, √3 subtract pi by 2 r squared is the area of my shaded segment. That's all there is to it. I hope that was useful to you. Thank you very much, and we'll see you for the next problem.